In this lesson, we will briefly examine two early number systems. Let's start with ancient Egyptian hieroglyphics. These were developed around 3500 BC, and in this number system, an additive approach was used to express every single numeral. All of the symbols are listed in order from left to right, going from largest down to smallest. Now, the way their system worked was assigning a symbol for each one of these values, and I'll go ahead and write them all down here. Starting with 1, the symbol was a straight line. For 10, it was this shape here. For 100, it is a spiral. For 1,000, it is supposed to be a flower, so something that looks like this. For 10,000, the symbol, the hieroglyphic looks like this. 100,000 was this here, so something that I think represented a tadpole. And then for 1 million, a person, so this here. The nice thing about this number system is the simplicity it uses to write down numbers. For example, let's say you want to express 137, our base 10 number, using these hieroglyphics. You'd start with the largest amount, which is this 100, and you'd write the spiral exactly once to represent 100. Now, for this 3, which represents 30, you'd write down the symbol 10 a total of 3 times. So 1, 2, 3. And then for the 7, which is in the ones place, you would write this symbol 7 times in a row. So 1, 2, 3, 4, 5, 6, 7. So these two are equal to each other. And notice that this is written with the largest going down to the smallest as you go from left to right. So as I said, the simplicity of this system is nice. A drawback being you might have to write a symbol many times in a row. Let's try a couple of other examples on the next slide. In example 1, we're going to write the following as either Hindu Arabic numerals or as ancient Egyptian hieroglyphics. Let's start with this one here. Since it's already in hieroglyphics, we'll translate it into Hindu Arabic numerals. And this one actually is not written correctly. These symbols here represent 1. This symbol here is for 100, and this is for 10. So technically, this is really not written in the correct manner, so I'll just cross that out. Really, this should have been written with the largest values first, which is the 2 spirals, followed by these 4 symbols here, and then 3 ones at the end. So each of these are 100, each of these are 10, and each of these are 1. Therefore, if you write this in Hindu Arabic, it'll be, well, for the first 2, we get 200. For the next symbols, we have 40. And then for the last, we have 3. And we can write this as 243. And that is it. Let's try that again here. So we're going to translate this into Hindu Arabic. This symbol here represented 1,000,000. These 2 here, I believe, represented 100,000 each. These here were 1,000. These are 10, and these are 1s. Therefore, when we translate this, we'll have 1,000,000. For the very first symbol, there's only 1 of them. Since there are 2 of these, and they're individually 100,000, that means we're adding 200,000. Each of these are 1,000, and there's 2 of them, so that's 2,000. I'm running out of space, so I'll continue it down here. Each of these are 10, and there are 4 of them, so that is 40. And then, let's see, we have 5 of these, and each one is 1, so that's a total of 5. If we combine this into a single Hindu Arabic numeral, that will be 1,202,045. Now this one, we're going to go from our base 10 Hindu Arabic into hieroglyphics. So how do we do that? Well, here we have a 1 in the 10,000s place, so I need the symbol for 10,000. Here I have 1 in the thousands place, and I know that this is the symbol here. This is the hundreds, which is the spiral. This is the tens, which is this symbol. And then this is the ones, and therefore we would use dashes. So if we put this all together, for the first 1 in the 10,000s place, we use this symbol here. Now in the thousands place, again, there's a 1, and we use this symbol, so I'll put 1 of those. Now here we have 9 in the hundreds place, which means we have to write 9 spirals in a row. Okay, so if we do that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, next we have to put 7 of these, so that's 1, 2, 3, 4, 5, 6, 7, followed by 9 of these symbols, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So to express this number in hieroglyphics would be written like this. So the simplicity of the system is nice. The unfortunate thing is if you have 9s or 7s, well, now you're writing a bunch of symbols in a row. The other number system I'd like to consider in this lesson is the Roman numeration system, which was developed around 300 BC. You could actually just say Roman numerals, that would be fine too. For this number system, it does use an additive approach and shares that in common with hieroglyphics, but it actually also uses a subtractive approach as well in certain cases. And for this reason, it actually makes writing some numbers shorter, which is nice. The basic convention is if the symbols decrease in value from left to right, you can add those values. But if they increase from left to right, it turns out that you subtract them. One thing that this system has in common with hieroglyphics is it uses 7 symbols, but it doesn't go up to 1,000,000. It actually stops at 1,000, but also uses 5, 50, and 500. I'm going to write the symbols down that are used in Roman numerals. They're all capital letters. So for 1, the letter that is used is capital I. For 5, it's V. For 10, it is X. For 50, it is L. For 100, it is C. For 500, it is D. And then for 1,000, it's M. To get a feel for how this works and what these two rules here are trying to say, let's look at a couple of examples. So to start with, I'm going to write down the Roman numeral CXVII. What is this in a base 10 number system? If you look at each of these, CXVII, we are decreasing as we move from left to right. And if that happens, we can simply add the values of each number going from left to right. So starting with C, that is 100, so I'll put 100. To that we will add X, which is 10. V is equal to 5. And both of the I's are equal to 1. If we add these together, let's see, we get 117. And that's it. So in some cases, very similar to the hieroglyphics. We are decreasing in value. We can simply write down what each value is equal to and add them together. You could also reverse this process. We could go from a base 10 number into Roman numerals. Maybe a simple example of that would be something like 31. What is that as Roman numerals? Again, this will be very similar to hieroglyphics where, oh, well, for the 30, we have 10. We could write this 3 times in a row. So 1, 2, 3, that is 30. If you'd like to add one more, we have a value, a symbol for 1, and you can put I at the end, and we're done. But what about this thing here? If the symbols increase as we go from left to right, we subtract. Like what's happening here? I think to illustrate that, I'll look at this, XC. What is this Roman numeral as a base 10 number? Notice we're going from 10 up to 100. In this case, and specifically if you have 2 Roman numerals next to each other that increase, you subtract this 10 from this 100. So this is really thought of as 100 minus 10, or 90. This is nice. This saves you the number of numerals that you have to write. Without this convention, if you wanted to write 90, you might have to do something like 50 plus 10 plus 10 plus 10 plus 10, 50 plus 40. If you were to write that, 50 is L, and writing 10 4 times gives you this. This is what you'd have to write to represent 90, and this is 5 symbols. Here it's just 2. And so for this reason, we won't do it this way, but we'll do it this way. Now we could also do this process in the other direction. So what about if we start with a base 10 number like 9, how could you express this as a Roman numeral? Well, you could do 5 and then add 1 a total of 4 times, But a faster way to do it would be to take 10 and subtract 1. So you can actually write ix. So here, this is 10. We have two numerals that are increasing, and you can subtract the previous one from it. So this is definitely the way to go. Like I was saying, you could say, oh, well, you could do 5 plus 1, 2, 3, 4. But here, again, we're using 5 symbols as opposed to just 2. Let's make this convention of when to subtract just a little bit more clear, and then try a few examples. Here, I've written the convention of when subtraction will be applied when using Roman numerals. You can only use these symbols in subtraction. And more specifically, I can only be subtracted from V and X can be subtracted from L and C can be subtracted from D and M. These are the only cases. So we can actually list them all out, which I will do an example to. Let's say you'd like to write 4. What you can do is you can say, I'll have 5 and take away 1. So 4 will be written as IV. We talked about 9 on the previous slide. Instead of writing V followed by 4 I's, you can go up to 10 and take away 1. For 40, the quickest and shortest way to write this would be go to 50 and take away 10. So you can write this as XL. And 90, you can say this is 100 minus 10. So 100 minus 10. So that is equal to XC. There's only 2 more to consider. You can subtract 100 from 500. That'll give you 400, meaning you will write it as CD. And then to get 900, you can take 100 from 1,000. So you'd write that as CM. So if any of these appear within a Roman numeral, meaning you have 2 that are increasing next to each other, we know exactly how to write those down. I put just a couple of others here. 3, we write this as simply I. We would not say, let's take 2 away from V. So we wouldn't do it this way. If you have 3, we'll just list 3 in a row. Same thing goes for 80. If you want 80, you can say, well, we'll start 50 and we'll add 10 a total of 3 times. We would not say, oh, well, if you're at 100, you could take 10 away twice. I mean, that is 80, but that's just not the convention that we use in the system. Let's try this convention out in example 3. We will convert Roman numerals into a base 10 numeral. But let's be on the lookout for pairs of numerals that increase, and we'll use that when we decide to subtract. So here I have MIX. So here this is 1,000, then it drops down to 1 and goes up to 10. And here we have 2 numerals next to each other that are increasing. And we've already decided that, well, if that happens, we're going to call that 9. So if we start with M, which is 1,000, what we will add to that is 9. Because if you see IX, this is increasing, and we subtract the previous one from X. In short, this is simply 1009 as a base 10 number. In this next one here, we have CCC XLVI. The C's represent 100, then we drop down to 10 and go back up to 50. So here we have 2 in a row where we are increasing, and then the V and the I are decreasing. So when I look at this, the 3 C's are each 100, and since we have 3 of them, that's a total of 300. But with the XL, L is 50, 10 is less than it, so therefore we take 10 away from 50, and that gives us 40. After that, we add V and I, which is 5 and 1, and the sum here is 346. Now if we compare this to MDC, LXXXI, these are all decreasing, 1,000, 500, 100, 50, 10, and 1. So here we can simply just add them all up as we go from left to right. So we start with 1,000, then we add 500, then we add 100, followed by 50. There are 3 X's, which is 30, and then 1. So let's see, this is 1,681. So 1,681. Final one here. MCMXCVII. Okay, so M is 1,000. Then we drop down to 100 before going back up to 1,000. So here I have two next to each other that are increasing. So this C and M means we're going to take 100 away from 1,000, which is 900. Then we have X, C. Okay, so here's 2 again, where we're increasing from 10 up to 50. And this means we subtract 10 from 50, which is 40. So I have to deal with this here. And the last 3 numerals are all decreasing. So, okay, here we're fine. So if I start with this M, that means we're going to add 1,000. And then to that, M is 1,000. We're taking away 100. That's a total of 900. Okay, that's followed by, well, C is 100, and we're taking away 10, so that is 90. And then the last 3 is 5, 1, and 1. So that's 5 plus 1 plus 1. So this is 1,997. 1,997. And that is it for this example. Let's look at one more convention that appears within Roman numerals. If you compare hieroglyphics to Roman numerals, you notice that, well, Roman numerals only go up to 1,000, but the hieroglyphics went all the way up to 1,000,000. So how do Roman numerals concisely express large values? And the convention that is used is to write a bar above the given numerals that already exist. So if you see X, which means 10, and there's a bar above it, that means you multiply that value by 1,000. Here, M itself means 1,000, but a bar over top of it means take that and multiply it by 1,000 as well. So let's try this out in example 4. Let's take these Roman numerals and convert them into a base 10 number. For this one here, X with a bar over the top means X is 10, and we are multiplying it by 1,000. That is a total of 4 zeros that will appear after a 1. So here's a concise way that you can write 10,000 in Roman numerals. For M with a bar over top of it, well, M itself means 1,000, and then we're going to multiply that by 1,000 as well. So this is a 1 followed by 6 zeros. So 1, 0, 0, 0, 0, 0, 0, which is 1,000,000. So even though there isn't a unique symbol for 1,000,000, there is still a concise way to write it within Roman numerals.